Okay.
Next part, system prediction. Consider the distribution system with three goal points. There are three goal points here. Primary gravity indices are shown in the first step. Allocate the repair, as we discussed, repair line or outer elevation. And this is what is this? U is annual outage rate. R is the outage rate for the component, whereas U is annual. Number of customers, kilometer distance. Number of customers or road points. And average road cost. Etc. Very right. So again we are going to calculate. Estimate the customer load what is SCI cycling design? Total number of customers served. Yes, 450. Total number of customers served is 450. Right? 450. And what is the number of customer interactions? Right? Next one is total number of customer interactions. Summation lambda n is 450, and we have to find out summation lambda n. 0.289. So what is lambda n? Check. Denominator is 37. Total number of customers. Whereas summation lambda n is 1037. So how I have found out lambda into n, that is number of customers connected to L1. What is that? 334. Right? 334 into J34. Let's check. Yes, 334 into J34. Lambda is 9. This is 335 into J35, 336 into J35. We are simply multiplying lambda into the number of customers connected to a particular load. And then we are adding them up. To get 130. Right? So cycle in this case is 130 divided by 450. So right now you know 130 divided by 450. It is 130 by 450 is 12.289 is not. Next is SAIDI. This formula you remember. This is total number of customer interactions divided by total number of customers affected. Okay, so interactions will be same. Summation lambda n it is 150. Yes. What is it? 34 into L32. So we are actually finding out summation number of customers into hours per year average. एक इक्वेशन का ये देखो. In citing we are actually computing number of hours per year because here it is duration is there. This D stands for duration. Okay. So we are computing duration into number of customers. That summation is equal to 785. 785 divided by 450. So this should be 785 divided by 450. Well, on the previous one is different. The difference is that in the first case we are considering only values per year, whereas in the second case, cycle case, we are considering the duration, the value per year. We are considering the duration. You see here it is D34 into L34. We are multiplying it. Whereas in this case it is D34 into J34, the value of it. Okay? Okay. Next is CIDI. What is that? Check the formula first. Sum of customer is summation EY and what was EY like? Summation EY like 785. 785 divided by summation lambda is 1. 785 divided by 1. Okay. Check this. 785 divided by 1. Note that if you don't write the unit, if there is a unit, then half mark will be deducted. Okay. So always check the units. Many students are doing the compute correctly, but they forget to write the units. So marks will be deducted. So write units. This is what is ASAI? Customer hours are available to service by customer hours demanded. Total customers summation EY NI by NI. So we have to get it from the Excel. You see here, D37 is the total number of customers. 450 into 860. We have also 450 into 860 minus N37. What is N37? N37 is summation LY NI. And ASQI unavailability index is 1 minus this 1 minus energy not supplied, just like the previous case we will compute it. What is the load connected here, average load connected here, and what is the duration? Average load connected into duration. Average load connected into duration. So it is computed here. See here. So it is F34 into F34. F34 is the average load connected to that load point. So F34. L34 is the hours per year duration. Okay. So total energy not supplied is this much kilowatt hour. The load is kilowatt hour. Load is kilowatt hour. Yes. So this is this much kilowatt hour. So you add it up. So this is the total energy not supplied. 3550 kilowatt hour per year. This is the total energy not supplied. 3550 kilowatt hour per year. And average will be simply total divided by number of customers, which is 450. Right? This divided by 450. Yes. J46 divided by 450. Comes up to 720. Right down. So we did two things here. Basically, in first case, system performance and prediction. In this case, some kind of historical data was given. Process execution is exactly the same. In this case, some kind of historical data was given. So we just estimated the performance. And in this case, These are basically what are these? These are distribution system. And these are of two types. Okay. Two types are, one is customer oriented, that means the outage etc. Oriented. And one is the load oriented or energy oriented. Energy not supplied, that is load oriented. These are the basic techniques for distributed system reliability evaluation. Now same is we are now going to apply to a radial distributed system. So these are applicable for all kinds of distributed systems. So we are going to be using for a radial system. In CS specific radial system and check how these indices can be computed for the radial system. So applications to radial system. As you know, most of the radial systems, most of the distributed systems are radial systems. Because they are very simple to construct. Many distributed systems are designed and constructed as single radial systems. There are additionally radial systems which also constructed as mesh systems and operated as single radial feeder systems. So two kinds of systems are there. One is radial systems and mesh systems. But mesh systems are sometimes operated at radial by using normally open points in the mesh. So to open a point in the mesh, it becomes radial. The purpose of this normally open point is to reduce the amount of equipment exposed to failure or any single pressure. The advantages of mesh system is that if there is some power failure, some component failure, you can have an alternate route. That is the advantage of mesh system. But it's very complicated. Also, you should know that in the electrical system failure due to the single maintenance failure, normally open point can be closed and another open in order to minimize the total load. So when we evaluate the reliability of the radial distribution system, what exactly we are going to do? So we write down the last point. For radial systems, the objective is to evaluate for radial system, the objective is to evaluate the three primary indices. So what are the three primary indices? Failure rate, repair time and unavailability. You have already written. What is failure rate? What was the formula? Lambda. Already written. Maybe. Last class we written three formulas, different formulas, basic formulas. Lambda, R and U. Okay? Tell me. Lambda. What is the formula? Summation of lambda I. Lambda is like series system. Lambda is. So it is simply summation of the individual component failure rates. What was the other thing? Next one. US or R? Yes, US. So that is equal to. Alright. Divided by. Only this much. And then third, RS is equal to US yes, right? Always remember this three because these are the basic indices. So three primary indices. These are the three primary indices. So highlighting your row. These are the three primary indices. Okay. RI, as I told you, is not exactly repair rate of it is actually the outage duration of the individual component. You can think like that. Outage duration of the individual component. And then customer are load oriented. All these indices you have to evaluate. So first you evaluate this tree. Then using this tree, you will compute all these indices. These are very much used nowadays also for evaluating the reliability of estimates. Did you write this too? Draw this radial system. Draw this radial system. So, in a radial system, you have got a supply from one side. These systems can have different supplies. Okay. So, there is only one supply side in the radial system. What is this? Circuit breaker. Circuit breaker. This is circuit breaker. So, you have got one feeder. This is the feeder. And these are the distributors. And these are the load points. A, B, C, D are the load points. Load points. And these are the sections of the feeder. 1, 2, 3, 4 are the sections of the feeder. Consider the above system, single line interpretation, and assume that any fault single phase or otherwise fits all the three phases. So we are considering only single phase. It is normally found in practice that lines and cables have a failure rate which is approximately proportional to their length. Okay. This is actually feeder and distribution is what? These are lines, transmission lines. Distributors in fact are something that are connected to a home where you are getting supply. All the component failures are short circuits, and each failure will cause the main breaker to operate. So anything else, any fault anywhere in the system, this breaker will operate. There are no points at which the system can be isolated, and each failure must be repaired before the breaker can be reduced. So any failure anywhere, that must be repaired first. So that means it is like, suppose there is a fault with customer B, then all other customers must be down. Unless their low point fault is cleared, otherwise you cannot get the supply. Because it's a radial system. It is a mesh system, it would have been possible, but not in this. There are no points at which the system can be broken. Following above procedure, the reliability indices for each load point can be evaluated. So what is exactly our objective? Our objective is to find out the reliability indices at this customer points A, B, C, and D. But to obtain those reliability indices, we need to find out those three terms: lambda, U, and R. Only way to obtain that, then only you can obtain all this. This is the problem. So main feeder. Main feeder is the top line. Main feeder has a failure rate of, right now is don't write the details, just write. Feeder has a failure rate of 0.1 failures for the nuclear earlier. And lateral distributions, small ABC have a failure rate of 0.2 failures for the nuclear earlier. Using this data, line length and line length, using data and line length, the reliability parameter shown in the following. So one part is already calculated. Lambda and R is given to you from past data. So these are the lengths of the sections, and these are the lengths of the distributors. Remember, you have written sections of the feeder 1, 2, 3, 4 like that. You have written sections. Right? Section of the feeder. Yes. So these are the lengths of those sections, and this is the length of the distributor. And the corresponding lambda and R values are given. Write it down. Okay. Now we are going to solve this. This is the data for the distributors and feeders. What about the customer data? These are the customer and load point data. Unless you know the number of customers and demand, how are you going to calculate the side in side? These are the data information. average demand for these four load points are 100, 100, 700 and 500. These are the number of customers and these are the current values. 5,000, 2,000, 2,000. For the above system and we look at compute lambda S US, right? What मतलब इनका lambda S US and RS, right? RS RS और अलग अलग विधि RS at each load point which is the principle of this. So this means these are the three basic indices. जो objective function these are the three basic indices. So average क्या पढ़ा? RS. This is US अलग अलग. And even with all this. So did you write the load and customer data? First part is to compute the basic indices, three basic indices, right? R, lambda, R and U. So what is the formula for lambda? Summation of lambda for each of the components. Now, if you see the diagram for load A, since there is a series system, as we discussed, any failure at any point of the system will cause the breaker to operate. So lambda into and R will be same for all the load points, okay, because it's a radial system, okay, and every such any component failure will result in this load point A failure. So we need to add up all this. You add up all these things. This is A72, A50, A72, right? That means you are simply adding up the failure rate of all the components. Now, the question again I will ask: why we are adding up the component failure for sections or feeder sections or distributed sections for say point number B, C, D for computing the lambda for A? Why you are doing that? Ideally, for load point A, only those who are connected to load point A should be added. But we are actually adding up all. Every section, 1, 2, 3, 4. Every distribution and BC. Why? Because what? Yes, because it's a series system. Any failure will result in a feeder D. Suppose there is failure at feeder D, then also the breaker X will operate. So we add up. This is lambda. Now what is the formula for R? What is the formula for U? What is the formula for U? Lambda R. And what is the formula for R? This is unavailable. Is you given in the question? Is you given in the question? No. We have to compute it. So if you see here, A7 into L7. That means R into lambda. Summation lambda R into lambda. Okay. This is lambda into R, and if you add it up all, summation lambda I r u equal to summation lambda I r. Is it the formula for you? Is it the formula for you? Yes. So what is that is what I do? Summation lambda I r. So we add it up. This is the value of r. Rs. And this is the value of lambda s. Now this is u. And this is equal to rs, which is equal to lambda divided by u. Summation of lambda I r is u, right? So that means this is 6 by 2.2. Equal to 6 divided by 2.2. How much? 6 divided by 2.2. 6 divided by 2.7. That means this is correct. 2.7. So these are the first objective cleared. 3 basic indices. So these are the basic indices. Now as we discussed, since it is a radial system, the 3 basic indices will be same for all the locals. So these are repeated across all the locals. So we see here 2.2, 2.736 are repeated across all the locals because it's a series. Now your task is now to compute this. Okay. So for this you need the customer data.